Alright class, so this video is about solving absolute value equations and inequalities. First I'm going to review what an absolute value is and how we can recognize it with its symbol, and then we're going to look at how to solve absolute value equations. Okay, so just a quick review of what an absolute value is. An absolute value means how far a number is from zero. Okay, so if I have these two numbers here, I have -6 and I have +6. If you look at how far both of these numbers are away from zero, if I look at +6, we know this is 1, 2, 3, 4, 5, 6 units away from zero. So the absolute value of 6 is 6. Okay, that's how we would write that. And if we look at -6, we see that it's also 6 units. 1, 2, 3, 4, 5, 6 units. It's also 6 units away from zero. So the negative one, we would say, well, the absolute value of -6 is also 6. They both are 6 units away from zero. That's how the absolute value works. The absolute value has these symbols. We call them they're like bars of two lines on either side. So when we go to solve equations, when we're solving, you have the absolute value and you have the x inside of the absolute value. We have to look at the positive and the negative solutions. Okay, so to set this up, what we say is, well, x is equal to 4 and x is equal to -4, and there's nothing else to solve here, so we just say that the solution, and we want to write this, it's solution in set notation, would look like this. You use these squiggly brackets, well, actually they're called curly bracket, and you just list out the answers. Okay, remember, when you have these curly brackets, you're just looking at the whatever's inside. You're not looking at it like as an interval. Okay, so same thing here. We have x plus 4, absolute value of x plus 4 equals 10. So we just split it. We say x plus 4 equals 10, and then x plus 4 equals -10. And this is the important part here. We need to make sure that once we split it, once we do the positive and the negative, we have to drop the absolute value symbol. Okay, I don't rewrite the symbols coming down here. I see a lot of students doing that. Just know that the way we can get rid of this absolute value symbol is by dropping it off by doing the positive and the negative. Okay, and then now we just solve this like we do any equations, but we just have to do 2 problems. Subtract 4, subtract 4, x equals 6, subtract 4, subtract 4, x equals -14. And then we have to write the solution in set notation, so we're going to say -14 and +6. Okay, and then this last question on this example has what is the absolute value of 4 equals -10? Well, remember, this number is it's technically the distance that it's away from zero, and remember that we can never have a negative distance. Okay, so we just say no solution because we cannot have a negative distance. Alright, so now I'm going to look at a little bit more complex problems here. So I have 3 different problems here. Before I can split it, before I can say +43 and -43, I have to have the left side just have the absolute value symbol. Okay, but if you notice, the -5 is not inside here, so we have to get rid of this first. So in order to do that, we're going to add 5 on both sides. So you have the absolute value of -8n is equal to 43 plus 5 is 48. And then from this point on, in order for us to, another thing, I didn't drop the absolute value, right? I brought it down with the -8n because the only way I can drop the absolute value symbols is by doing the positive and the negative. So negative 8n equals, let me write that better. Negative 8n equals 48, and then negative 8n equals negative 48. And then we just start solving this, keep solving. N is equal to negative, what's that, 6. And then negative 8, N is equal to positive 6. So to write this in set notation, we're going to say negative 6 and 6 are my absolute, my solutions to this problem. Same thing here. Before we start solving it, we got to get rid of this 10. So I'm going to subtract 10. Because it's being added, I'm going to subtract it off. Crossed out, so you have the absolute value of x plus 5 equals negative 6. And then when I go to split this, you notice how it's a negative here. I can't have that, so I'm just going to say no solution to this. Originally, the problem started off with the positive, so I kept going, but then once I took out the 10, I got a negative and an absolute value. This, we cannot have a solution to this. And this example here, we have the 8. So if you notice, the 8 is being divided to the absolute value, okay? So the opposite of division is multiplication. So on this one, I have to multiply both sides by 8. So that gets crossed out. So you have the absolute value of a minus 5 equals 8 times 3 is 24. And then we're going to split this. A minus 5 equals 24, and then a minus 5 equals negative 24. Okay, now we're going to add both sides. So you have a equals 29, and then add both sides. A equals 19, negative 19. Okay, and then we're going to just write this in set notation, negative 19 and then 29. Alright, so on the next page I have a few examples. I'm not going to go through all of them. I'll go through, let's see, I will go through number 9, 10, and 11 and 13. Okay, all right, so just follow along as I'm going through this. I'm going to do the positive, negative, drop the absolute value symbol, solve it. R equals negative 4, and then on this side R equals positive 6. So to set notation for this is negative 4 and 6. These are my two solutions. This one, if you notice that my 7 is being divided, so I have to multiply both sides by 7 in order to get rid of it. So you have the absolute value of a minus 3. Don't drop the absolute value yet because we didn't split it yet. So you have the positive, and then you have the negative. And just solve it. So what's that? That's 19, 18, negative 18. So my set solution for this is negative 18 and positive 12. 24. Number 11, for this one, I'm going to, the negative 18, to get rid of it, I have to add 18 on both sides. So you have the absolute value of x plus 4 equals 9 plus 18 is 27. And then we're going to split it. We're going to do the positive and the negative. X equals 23. X equals negative 31. So my set solution is negative 31 and 23. Okay. And the last one I wanted to do was problem number 13. Okay, so the negative 10 is being multiplied to my absolute value. Okay, I just want you to know that the absolute value, you cannot treat it like it's a parentheses where we distribute. We cannot do that. Don't do that. So the only way I can get rid of the negative 10 is by dividing both sides by negative 10 to get rid of it. So we're going to cross those out. So you have the absolute value of x minus 3 equals positive 4. Originally, you might have wanted to say, well, this is no solution because it's negative. But no, once we divide the negative 10, we get a positive number. So we can keep going with this problem. X minus 3 equals 4. X minus 3 equals to negative 4. Just solve it. Okay, so my set solution to this problem is negative 1 and 7. Okay, so the next part of it is we need to solve absolute values that have an inequality symbol. Okay, so the previous examples had just equal signs. Now the next examples we're going to have inequality symbols. So you might want to refer to the lesson on compound inequalities, where we kind of talk about this OR problem and an AND problem. And I did make a mistake on this sheet. Remember that an OR problem, it doesn't get graphed like this. It actually gets, goes the other way. So I'm going to fix this graph here, okay? It would look something like this. Okay, an OR problem, it would get graphed on either side. Okay, and then your AND problem, it gets graphed in the middle. Okay, sorry about that. Just if you want to make those corrections in your notes, that would be good. And again, this is the absolute value symbol. The graphs, it gets shaded in between. And then on the other side. Okay, so just let's take a review. So whenever you have a greater than or greater than or equal to symbol, it becomes an OR problem. Okay, so for example, you have these two examples here, and then you can look ahead and then we can graph it as an OR problem where it goes in opposite directions. Okay, and then we have the less than becomes an AND problem where it gets graphed in the middle. Okay, so let's go through our absolute value symbol inequalities. So for this one, we have it's a greater than, so we can greater than, so this is going to be an OR problem. And then let's get started by how do we solve this. So we solve the inequalities just the same. We start by doing the positive, drop the absolute value, and then we also do the negative. But for the negative 10, we have to remember to change the sign. Okay? For the negative part, we have to remember to change the sign. Right here. Okay? So now we can start by just solving these two. N is greater than 15. n is less than negative 5. So n is greater than 15. 15 is somewhere over here, so it's going to be greater than. You're going to shade to the right. And n is less than 5. It's going to be shaded to the left. Okay, so let's just keep going with these. I'm not going to do all of them. Let me do problem number 4 and 5. If you notice, 4 is an OR problem, so we can expect the graph to go in opposite directions. this is an AND problem because it's less than. We can expect the graph to be graphed in the middle. Okay, so for this one we're going to do the positive and the negative. So we have r plus 8 is greater than or equal to 9, and then we have r plus 8 is less than or equal to negative 9. And then we're going to subtract. R is greater or equal to 1. Subtract. R is less than or equal to negative 17. So when I go to graph this, r is greater than 1, so I'm going to greater than or equal to 1, so put a closed circle, and then we're going to graph it. R is less than or equal to negative 17, so somewhere over here, negative 17. We're going to put a closed circle and then shade to the left. Problem number 9, so we're going to say x divided by 9 is less than 5, and then x divided by 9 is greater than negative 5. Just make sure to flip the sign because for the negative. And then we're going to multiply both sides by 9. X is less than 45. Multiply both sides by 9. X is greater than negative 45. So if x is less than 45, let's just say 45 is somewhere over here. We're going to shade it to the left. And then x is greater than 45. We're going to shade it to the right. So this, you can see, it looks like an AND problem. And then here we have more complicated problems. I'm going to go through problem number 6 and 7. Okay? Alright, problem number 6, we're going to have to deal with this 10. So just like the previous problems, we're going to multiply both sides by 10 to get rid of it. So you have the absolute value of negative 9m plus 2 is less than or equal to, the 10s get crossed out, 50. 5 times 10 is 50. And then you have negative 9m plus 2 is less than 50. And then negative 9m plus 2 is greater or equal to negative 50. Now we're going to solve it. I believe this is a fraction. 48 divided by negative 9 is, yep, negative 5.33. That's okay. And then here, subtract 2, subtract 2. Alright, so I subtracted the 2 and I got negative 52. Then I'm dividing by negative 9. So remember that when you're dividing by a negative number, we have to change the sign again. So 52 divided by 9 is 5.77. Okay, so we're looking at m is less than negative 5.3. Oh, sorry. Oh, I didn't do that here. Divide by 9 here, divide by 9, so I forgot to change the sign here as well. See, I'm moving way too fast on this. So m is greater than negative 5.3. M is greater than 5.3. So I'm going to put a closed circle, and I'm going to, actually, I'm going to move this over a little bit. Negative 5.3 would be actually over here. And then to the right, and then let me graph this one. M is less than 5.7, so 5.7 is over here, and then it gets shaded in the middle. Okay. All right. Problem number 7, the last example I'm going to do today for this lesson. We're going to divide by -7, divide by -7. Again, anytime you're dividing by negative, remember to flip the sign. So here we have the absolute value of 7b plus 1 is less than -91 divided by -7 is 13. So and then we're going to split this. We're going to say 7b plus 1 is less than 13, and then 7b plus 1 is greater than -13. So change from a greater than problem to a less than. So I can expect my graph to be shaded in between. If it doesn't, then we did something wrong. 12. So this is going to be a fraction as well. So 1.7. And then oops, where did I get this equal from? B is greater than -2. So hopefully my graph will work out how I want it to. B is less than 1.7. Somewhere over here, it's got to put an open circle. -2, put an open circle. So B is less than 1.9, so it's gonna go here, but B is greater than -2, so it goes back over here. Remember that this is greater, this was an OR problem, but then because we divided by this negative, it changed to an AND problem. Okay, so it got shaded in between. And then here, I just have some multiple choice questions here for you to try. It's the same thing. You just have to solve it and then look for your answer. And then some more multiple choice questions for the inequalities. Okay.